Hello and welcome to the InterPlex. Ciro Cattuto is an Italian physicist and complex systems scientist whose broad research interests have resided at the dynamic intersection and entanglement of human behaviors and digital platforms. He is the scientific director of Turin, Italy-based ISI Foundation, where he has worked since 2008, and he is also the founder and principal investigator of the Sociopatterns collaboration. Cattuto has also held various impactful research, fellowship, advisory, and board member positions in Italy, the US, and even in Japan. Our thought-provoking InterDialogue touched on Cattuto's personal path from theoretical solid-state physics to complexity, a multicultural journey which spanned 3 continents. And we spoke about his early work in data and complex network science, which focused on the first digital social networks. We also spoke about how to more rigorously define and foster interdisciplinary research, with his key role in helping to bridge the fields of complex networks and epidemiology serving as an important case study. We further spoke about the interdisciplinary research areas and core principles of ISI Foundation, centered around computational social science, the social impact of data science, and increasingly the exciting possibilities and deep concerns around the integration of AI into data science, research, and society at large. Hi, Ciro.
Hello there.
It's been great being with you here at ISI in Turin, Italy. It's really
great having you.
Thank you. Let's get started. I want to ask you first about your, let's say, personal path from physics to complexity. I'm particularly interested in the cultural influences. Okay. Italy has been something of a hub, a pioneer in complex system science. You also spent time in Michigan, also a center of complexity, but a few years in Japan as well. So I'm interested how all of this is kind of woven together for your path in life and in your career.
Yeah, Daniel, as usual, retrospectively it looks like it was planned, but actually it was not at all. And that's always something that I like to say, especially when the audience might include young people, because I don't want to project the idea that we can engineer these things. These things largely happen. And it was like this for me. Like I studied theoretical physics at the University of Perugia, and got passionate about early on about complex aspects in solid-state physics, and then ended up studying nonlinear solitons in lattices, and back then there was an active community working on Sine-Gordon 5-4 models where you had quasi-particles that existed only at the mesoscale level. So I guess that was my initial inception of curiosity on complexity, and then during my final year of PhD, I spent it at the University of Michigan at the program for the study of complex systems. In Perugia, my mentor was Professor Marchesoni, who is a leading expert in stochastic processes from the statistical physics side. Luca Gammaitoni as well. And then at the University of Michigan, I was mentored by Professor Franco Nori. Back then, the community that then went to network science, before that the community was focusing on, at least a branch of the community was focusing a lot on redoing statistical physics where the elementary interaction is dissipative. And so we were all working on granular materials. You might remember like this wave of activity on working out what happens when you don't conserve energy at the elementary level. And there were like some applications that were of interest, but the reality, I think, is that it was really an interesting exercise to explore this new space. I was one of those persons. Mostly I was doing numerical simulation of granular systems. Back then we were already using Python. It was very early on, and we pioneered a couple of simulation patterns that now became dominant. For example, the idea of writing the core of the simulation engine in C, and then creating bindings to the Python languages and orchestrating the behavior of the simulation from Python. And then this became, like a standard way of proceeding. So yeah, I had a lot of curiosity on the computational aspects. Then Japan really happened pretty much randomly, because my mentor at the time got an offer at Riken in Tokyo, and he offered me and other members in the team to follow him, keeping on the same work. I initially accepted for just 6 months, and then I loved Tokyo so much I ended up staying more than 3 years. And in Tokyo, I kept focusing on granular matter, but these were the early days of online social networks. And I started being curious about those. To me, the idea of seeing human behaviors, to say it better, to see digital traces of human behaviors in online system was very interesting, because it made the system observable. And a lot of the ideas from complex systems, including networks, were immediately relevant for this.
What years were these?
This was 2003.
Okay, yeah,
roughly.
So early years.
So I was playing around with systems like, you might remember, Delicious for social bookmarking, Flickr. It was an online social network still existing, where people would tag and connect around photos. I was spending a lot of time in Tokyo as a photographer. And so, like, actually, I got to know Flickr because of my passion for photography. And then once I started, acting within that system, I realized that I was part of a complex systems growing. So that captured my attention, and I really flipped my research agenda. I started working on that. And then at some point, I decided to come back to Europe, and I had a couple of paths available, but one was back to Italy at the Enrico Fermi Center and Sapienza University in Rome, which, as you know, is one of the cradles of many ideas in complex system science. My mentor then was Vittorio Loreto, who's now at Sony CSL and still at Sapienza and Enrico Fermi Center, of course. And Vittorio was enthusiastic, like me, about modeling linguistic exchanging and collective behavior in online social networks. So with Vittorio, we started collecting data and then using ideas for complex systems to model some of the properties. The community was still, at the time, focusing a lot on emergent heterogeneity and emergent power law regularities. So we did some of that work in these systems, creating minimal models that would explain some of the heterogeneity we would observe in real systems. And then it was an exciting time back then at Sapienza. I got to know many of the actors of network science and complex systems: Alessandro Espignani, Guido Caldarelli, a lot of other people with whom the exchanges were really fruitful. Luciano Pietronero, who actually is the person who opened the door for me at the Enrico Fermi Center, and so I became like closer to that community, and when at some point Vittorio Loreto and Alessandro Espignani decided to have a team here in Torino at ISI, this was around 2005, 2006, I accepted the job offer here, initially as a postdoc, then as a group leader, and then 20 years have passed, and I grew in this position thanks to to these people that I mentioned. It's interesting that the first European conference on complex systems, you might remember the ECCS conference, which was one of the leading venues for many years on the science of complexity, and then became the Conference of Complex Systems with a global span. The very first European conference on complex systems was held at ISI Foundation in 2004 at Villa Gualino. I was not at ISI yet, but this is one of the events that really pinged in my radar and made me understand that ISI was maybe a place where I could be a platform to explore more. So yeah, initially we continued on online social networks. Phil Mengzer was on sabbatical at the time at ISI Foundation, so we collaborated with Phil. And then I started collaborating a lot with with the person who became then my closest collaborator and friend, who is Alain Barra. Back then he was at Orsay, and then soon he transitioned to the University of Marseille. And with Alain we created Sociopatterns. We created this project that has been running by now 18 years on using wearable proximity sensors and devices to measure human mobility and proximity at the scale of the meters and the seconds. So we started measuring networks of human contact and proximity with applications to computational social science, infectious disease dynamics, and more. So yeah, that's roughly the path. And as I told you, retrospectively, it looks logical, but no single action actually was planned with a long advance. I really navigated opportunities that opened and closed, mostly by chance, I have to say. So I'm very grateful to these opportunities, but mostly to the people that were mentors in different periods. Alessandro Espignani has been at this point one of the key persons for me, but also the community at ISI at the time: Vittoria Colizza, Santo Fortunato, José Ramasco, many people who bind this community.
Yeah, great. I want to ask you about interdisciplinarity.
Yeah.
We'll get to more of the work of ISI, but
sure.
Just as a kind of a broad topic that's been very interesting to speak to you about, what is interdisciplinarity, and what are some examples of how here at ISI and other work you've done has been able to actually build interdisciplinary collaborations?
Yeah, I think it's by now it would be more simple probably to say what interdisciplinarity it is not, in a sense. It's in a sense we all abuse a little bit the term. To us here at ISI, we try to adopt a stricter stance, and we ask our researchers to strive to publish in venues of all the disciplines that are relevant to their work. So if we have work in network science that's relevant to epidemiology, we try and publish in the epidemiology journals and not just in the complex systems and the network science journals. So this is something that this is the bar we set, and we think that this is what in the long run breaks walls between disciplines, because it gives legitimacy to careers that happen at the interface. And of course, it's always difficult. At ISI, thanks, I think, to the work of Alessandro Espignani, Vittoria Colizza, Alain Barra, early on, ISI broke this wall between epidemiology and mathematical modeling from complex systems. But it took a lot of time to become recognized, accepted.
About 20 years.
Build a reputation in the other community, get invited to the flagship conferences of the relevant communities. So it is a lot of work, but in turn, retrospectively, this then created space where there was no space, and this created opportunities for young people to have a career in a field that simply was not existing, or compressed, or had to be justified continuously. And the moment you create these spaces, and the moment you have maybe bold institutions who embrace standing in these new spaces, ISI is certainly one of these by mission, then you allow new careers, and these new careers down the line, and we see the effects now, they create a community that doesn't feel constrained by the disciplinary boundaries and collaborate freely. Right. And a lot of these collaborations then became the anchors for big funding efforts. As you know, in Europe we have the framework programs that require to have multiple partners from different countries, different members of the EU, and basically these networks of people who had an interdisciplinary training, they became the initial anchors for this work because they were already sharing a language. And even though they had very different careers in many cases, originating in different disciplines, but they were attending the same broad set of conferences in different disciplines, and they were tied by co-authorship with emergent or established like characters, figures in neighboring fields. And this enabled some pretty bold initiatives on complex system science and network science in Europe during the first round of flagship programs. It helps that back at the time there was a wonderful program called FET Open, which, contrary to many of the programs we have today, was open-ended. So there was no topic for this call. You could propose anything. And several of the efforts, several of the funding to the complex systems community in Europe came via this program, exactly because it was open to fund projects that had no clear disciplinary label attached to them. And unfortunately, this program became a victim of its own success, and the number of applications ballooned up so much that the success rate dropped, and eventually the entire program was folded. But it is a pity because like this type of open-ended funding initiatives, I think, are those we still need actually to push forward the interdisciplinary science.
To address larger, more complex problems. Do you think all of these initiatives and approaches have helped to inspire a new generation of researchers, aspiring researchers, that are not confined by a traditional siloed structure of academia?
Absolutely. I saw this with with the younger generation of researchers that I mentored and my colleagues mentored. They had, in a sense, the luxury, also the challenge, but it was mostly an opportunity, I think, of making PhD theses that were already highly interdisciplinary. This was not the case for my generation in many cases. And it's something that we had to, strive for afterwards, after a PhD that was more disciplinary grounded. This generation, this younger generation, had the opportunity to have their PhD training already squarely at the interface of disciplines or in interdisciplinary domains like network science or many of the other computational social science. And this is beautiful, I think, because it created then a new generation of young scholars who don't feel bound by disciplinary boundaries because they never actually experienced them in the way we did.
Right.
So I think this is
we were talking the other day about the importance of starting that earlier in graduate school at the PhD level. Or maybe
exactly. The other thing is that this, at least in Europe, these European projects created, like some of them had like deliverables that were community-oriented deliverables. For example, the European Conference on Complex Systems, the first one held at ISI in 2004, was actually a deliverable of a European project. Several schools on complex systems, network science, computational social science, were actually funded by the European Commission via these collaborative grants. And so this like networking and training opportunities really made a community. And so we were commenting on this like past week when we held here at ISI the Italian Conference on Computational Social Science. Despite being Italian, actually a lot of the community were Italians from all over Europe, and the largest community was from Copenhagen. And they were largely Italians, but still part of this community. So this witnesses to how much even not only disciplinary, but also institutional and national boundaries got dissolved by this process, and I think it's a wonderful thing.
Yeah, that's amazing. So you keep mentioning computational social science.
Yeah.
I'd like you to maybe define a little bit better what that is and what it applies to. But also at ISI, in addition to computational social science, what other interdisciplinary research areas are being focused on?
Yeah, I would say that at ISI, our scientific focus has been shifting over the last 40 years. ISI has 40 plus years of history. I've only been part of the last 15 years, 18 years of history of the institution, and it is in the nature of a lean, non-profit, soft money organization like ISI to continuously change focus. Nowadays, we focus largely on a modern vision of data science that includes network science, data mining, machine learning, increasingly AI, applied to broadly social impact and sustainable development with a strong vertical on computational and digital epidemiology. So on using non-traditional data sources and mathematical models from complex systems and computer science to reason about the spread of communicable diseases and interventions to mitigate that. In this domain, thanks to the work of Alessandro Espignani and his team, we actually cover end-to-end the entire pipeline from collecting data to creating models, to studying models in their abstract representations, working out sometimes analytically what you can, simulating them, all the way to devising forecasting systems, projections, and bringing them to bear on actual decision making and policy making. And in this sense, the COVID experience was a test of fire of this pipeline. Now, this is a general pipeline, though, and so we strive to apply what we learn in this context also to other domains, such as humanitarian response, sustainable development, broadly meant, understanding the causes of inequalities, poverty, climate change related crises, especially the shifting demographics, migrations, the shifting prevalence of vectors that transmit diseases. So we try to embrace this full spectrum, but I would say that our verticals are at this stage, broadly speaking, computational and digital epidemiology and computational social science, meant like studying old and new questions in sociology and in the social sciences by using new data sources, new data streams, and new methods from network science, complex systems, increasingly AI. I think what binds everything together goes back to the way we think as physicists about understanding a system, so a complex system, observing emergent phenomena, observing the structure of the system, and trying to connect, trying to come up with simple mechanisms that can be worked out computationally or analytically that distill the essence, the essential aspects of the system, and when simulating or analytically solved, let the features of interest emerge at the highest level, right? So I think it's still very much a vision of complexity, but a vision of complexity that increasingly has been abandoning the very simple models in favor of a realism that allows you to get closer and closer to the problem you want to tackle and to actually deploying decisions and policies. One thing that we do, that we try to do, we don't do it everywhere, but one thing that we try to do at ISI is to bring to bear the studies we publish to actual decision and policies, to bridge this last mile. This is also why we care a lot about governance aspects. A lot of the value, a lot of the decision-making capabilities and a lot of the value of AI today lies in the data that you feed into the models. And we consider data the level at which we should intervene. And so we've been working quite a bit, also in collaboration with think tanks like GovLab at NYU with Stefan Verhulst, on thinking about data collaboratives, data spaces. In general, creating common goods, new type of common goods based on data that is shared not necessarily with the public, but with a wide enough set of stakeholders so that you can generate value that otherwise is latent. And we really see ourselves at ISI as one enabler of more generation of public interest value from data and data-related technologies and methods.
Okay, and I want to ask this data-driven approach, the computational social science. Do you see much potential, perhaps, with the emergence of AI, of actually including social scientists in the process of research?
I think it's essential, right, as we were discussing. This is critical, and I think it's the direction in which, like, most of the leading centers are actually moving. Increasingly, a lot of the purely computational aspects are getting commoditized, and it's important to focus on higher and higher level questions. Our work will become necessarily more meta in many ways, and a lot of the abstractions that we will need, and a lot of the meta reasoning we need to lift from philosophy. We need to lift from the social sciences. It's also a huge opportunity scientifically, because for the very first time we are really starting to observe social systems that embed AI agents, or if you want, you can flip the script, AI systems that incorporate human behaviors and knowledge. No? This generation of AI is not really engineered, it's really grown, trained on top of human behaviors, and with that, the related biases and limitations. And we don't fully understand mechanistically how these systems work. So I think there is a massive opportunity of using methods from complex systems to study AI systems, ideas from time series analysis, dynamical systems, network science, and also like algebraic topology, higher order networks. So there is a lot to do there. So ideas from complex systems that we can use to maybe understand better these AI systems, or design new patterns to train them, or new architectures. But also there is the reverse side, where we have a new way of studying complex systems using AI. I mean, the role of simulation of complex systems is changing. Increasingly, we will see complex system simulators and libraries in the loop of an agentic process, driven at a higher level by a researcher. So this is a frontier that we are exploring also here at ISI Foundation a bit. But also then the higher challenge, the higher level challenge of what it means to have an AI-infused society, like Roberta Sinatra calls it at the Copenhagen Computational Social Science Center. The work of Taha Yasseri in Dublin, the work of Iyad Rawan, who was awarded, by the way, the Lagrange Prize by ISI Foundation, CRT Foundation last year. So all of these scholars are really, Andrea Baronchelli, all of these scholars are really studying how, using complex system tools, the interaction between human and AI agents regarded on the same footing, creating social networks where you have emergent phenomena, influence, opinion dynamics, linguistic alignment, fragmentation, all of the rich phenomenology that we know from the social sciences is now happening in front of us in real time, with huge challenges, because it is now known that injecting agents into the system and engineering like suitably the behaviors of this agent can actually steer the emergent properties of the system, no? Like the work of Nicholas Christakis on how agents in a social network can nudge the systems towards consensus or lack thereof. And so I think this is a very fertile, very rich ground for new research, and I think it will be exciting to see where this leads the field of computational social science and complex systems and network science, with the huge challenge that I think increasingly the scientific community has relatively limited visibility of the technical part of these systems. I mean, this is not new. Already when if you look at the history of computational social science on social media, initially there was a lot of visibility of these systems. There were open APIs. We could track a lot. And increasingly this access got restricted the more these systems got monetized. And during the last 5-6 years, the community largely lost access to these systems. With AI, there is the problem that training these models is not something any actor can do. These models, some of them are open, most of them are not. The way they are embedded in our fabric, in our social fabric, is largely something that we have to map. It's not visible. So I think there will be, again, governance challenges for research in getting the right access to data, but also amazing opportunities of using, for example, open models in experimental settings, in synthetic populations, or in population of real humans in synthetic settings. For example, I love the work of Ancho Sanchez in Madrid, where they actually carry out experiments, and increasingly they're with humans, and increasingly they're replacing some of the humans with agents to try and see like what are the new dynamics that it's possible to study. So it's a very rich ground, and I think it's a super exciting moment for our science. And this will have probably a much stronger translational impact that we've ever seen in our communities, I think. If I would have to guess.
Yeah, I'm seeing that as well. I mean, it's a very optimistic and exciting vision as well. Do you have any concerns as well?
Oh, of course. Like the concern are tied to the last comments I was making. That we are in a situation where the state of the art of the technology we need is no longer in academia, or at least it's only partially in academia. The resources to train these systems at scale and experiment are extraordinary, and so most researchers do not have access to those. And AI is in the loop of society in a way that, on the one hand, is more pervasive that we realize, and on the other, it's much less understood than we think. And I think that there are unknown unknowns, and therein lie risks, probably new risks for democracy, for autonomy, for human dignity, for our social lives. So in this, I think that our research can play a role by problematizing these things, by shining light and communicate it to the broader public that this is not just a positive technology-driven march to a brighter future. This could be actually also a descent into very dark times. And so we have, I think we have a duty, a renewed duty as scientists to speak out to the public and to explain what these systems are, to explain why they don't think in the sense we mean, why they are obviously not conscious. To also, like Alessandro Vespignani says, to diffuse their own questions and actually frame for the public and for the scientific community the right questions, which is, okay, this is happening, what are we doing, how do we embrace this, where do we push the brake, what does it mean to steer into the future a society in which there is AI in such a pervasive way? And I think that in the public discourse, we see a lot of distractions and a lot of stereotypical, relatively thin, unfortunately, discussions on AI, whereas now it is the moment and our responsibility to explain the complexity of this and to explain the extent to which we don't know and we cannot chart the future for the good and the bad.
Thank you for joining us for this InterDialogue. You can subscribe to be notified of future episodes and by following us on our social media channels at the InterPlex. Visit our website, theinterplex.org, for more interdisciplinary and intercultural content and to join our growing collaborative community.